Hey gang, so again, today we're going to be looking at some more radical functions and talking about ways that the square root of x is changed in the coordinate plane by manipulating the equation. Graph each radical function below and compare to the function y equals square root of x using the words reflect, shift, compressed, and stretch. So last year in Accelerated 7, you might have talked about these types of transformations before. So you probably saw on a coordinate plane graphing a shape. And if you have a shape like this, like a triangle, and you reflect it over the x-axis, it would look like this. But if you reflect it over the y-axis, it would look like that. So that's what I mean by reflecting. Shifting is when you just shift it over, you move it over. So all the points go in the same direction. So maybe I have a triangle that looks like this way over here, where all of those points were shifted on the coordinate plane the same number of points up, down, left, or right. Then compressed, you might have heard of as a dilation. So if you have a big triangle, you can then get a small triangle. Or if you have a small triangle, you can make it a big triangle by stretching. Okay, so compressing is when you make it smaller, stretching is when you make it bigger. All right, so let's take a look and see how this affects the radical function. So for number one, I gave you the equation y equals 1/2 square root x, and I have the y equals square root of x function here. You might actually hear this being referred to as the mother function because it is the very basic function for square root of x that all the other functions are created from. Okay, so from this, we're going to pull up the table y equals 1/2 square root x. And we're going to pull up the table and graph the values that we can see. So we have 0, 0. Then we have 1.5. Then we have 4 and 1. Then we have, if I scroll down further, 9 and 1.5. Scroll down further, 16 and 2. Scroll down further, 25 and 2.5. Okay, so this function is super, super low compared to the function, the mother function of square root of x. And what has happened here is we've compressed it all. So all the numbers, like square root of 25 is usually 5, but it's been cut in half. Square root of 16 is usually 4, but it's been cut in half. Square root of 9 is usually 3, but it's been cut in half. So it's compressing it. So by having this 1/2 out front, the square root of x has been compressed. Okay, so you're going to try 2 on your own or continue with the video and then come back to the evens later. Let's see the next problem. So number 3, we have y equals square root of x minus 4. So we go back, we pull up that function, square root x minus 4. Make sure that x minus 4 stays under the radical or you have parentheses around it if needed. Pull up the graph. And again, this time we start at 4. We have 4, 0. Then we have 8, 2. Oh, I forgot 5, 1. We have 13, 3. And we have 24. I don't think I'm going to be able to fit anything else. Let me just check. 29, 5 I can't fit. All right, so we draw this function. Now, keep in mind, in this picture, each one is worth 1, so it might look a little compressed here, but that's not really what happened. So if we look here, this started at 0, our function starts at 4. So this shifts the square root of x 4 units right. And hopefully you even see that in the equation with this minus 4. You would think it would be 4 units left, but it actually moves it 4 units right. Okay, so let's continue to see what else we can have done to this function. Number 4, we have the negative square root of x. So we go back to y equals, we clear. We do negative second square root x and pull up the table. Remember, instead of scrolling, I can press second window and go back to 0 very easily. So I have 0, 0 again. Then I have 1, negative 1. Then I have 4, negative 2. 9, negative 3. 16, negative 4. And 25 would be at negative 5. So it's the basic square root of x function, but it's on the opposite side of the x-axis. So what's happened is the square root of x has been reflected over the x-axis. And you can see the only thing that's different in the function than the square root of x is that negative sign. So it has to be that the negative is what did the reflecting. All right, let's continue. Number 7, now we have square root of x plus 4. We go back to y equals, clear what's there. Second square root x outside of the square root, we want plus 4. So you would close your parentheses if you needed parentheses there. Then pull up your table. And we start at 0 again, but we start at 0, 4. Then we have 4, 6. Oh, I missed 1, 5 again. Then 4, 6. 9, 7. 16, 8. And 25, 9. So you can see again that this has that basic shape of the radical function, but it doesn't start at 0. It's up at 4. So this, or I want to say the square root of x has been shifted up 4 units. And again, you can see that in the problem. So that up 4 happens from the plus 4 outside of the radical. All right, so hopefully you see where I'm going with this and you can try some on your own. So you're going to try the evens on your own or with a partner, then complete the last part of the notes. And at the end of the period, when I've seen that most of you are done, we'll have a discussion about the answers that you came up with.